In 1790, the first U.S. Census counted nearly 4 million people living in the United States. Since then, the census has been conducted every 10 years, and the 2010 count is underway. With congressional seats, electoral votes, and federal funding on the line, the results will have major political ramifications. Will the 2010 census be accurate? Are the current apportionment and districting systems fair? These are just some of the questions more than 2,400 high school students tackled as they competed for $100,000 in scholarship prizes at the Moody's Mega Math Challenge.
When most people would look at this problem and they would say, what does math have anything to do with government? And we saw the problem right away and we're like, math, math, math. So the idea was just to straight away just start looking up models for these things and applying them.
The task of simply counting Americans has become not at all simple.
The M3 Challenge is organized by the Society for Industrial and Applied Mathematics and funded by the Moody's Foundation.
One of the points of the Moody's Mega Math Challenge is that we want to teach kids that they can use math for anything. And I think rotating the problems among economic problems, political problems, social problems helps them understand that.
Previous challenges have included problems related to Social Security, energy independence, and the economic stimulus package.
This year's problem was about the census, and there were 3 parts to it. The first was how to correct the undercount of the census. The second was how to develop a new method for apportioning House seats. And the third was how to correctly draw legislative districts.
The annual competition is entirely internet-based, and there are no fees to participate. On the day of the challenge, the teams see the problem for the first time when they download it from the web. They then have just 14 hours to put together a detailed solution paper and upload it back to the contest website.
14 hours sounds like a lot of time, and it is, it's a whole day, but not when you have a very complex multi-part problem to tackle.
Many more people respond to the census than respond to the PES. So an error of a few people in the PES would correspond to an error of several hundred people in the final census.
I worked on the first part of the question, which was concerned with how the census should adjust for undercounting. So I looked at 3 principal methods and evaluated each method for what are the upsides, what are the downsides, is it worth it?
We realized that the number of seats is arbitrarily fixed. You can easily change it, and in doing so, you can greatly increase the effectiveness of the apportionment method.
I presented the third part on redistricting. We came up with 2 constraints that we asked states to meet in order to minimize gerrymandering.
After all teams have submitted their papers, panels of professional mathematicians evaluate hundreds of entries, eventually selecting just 6 of the teams to present their papers at the competition finals in New York.
Oh man, we're so excited. I mean, this was our first year doing it, first year from our school, anybody in our state really, but just a great opportunity.
I'm a little nervous for the presentation, but I'm actually awaiting what the judges have to say. I'm really interested in how they thought about our paper, as professionals who do this for a living.
Congratulations. Your team's solution has been judged to be among the top 1% of the 530 papers that were submitted.
Undercounting was the same as net undercounting, which took into account both the undercount and overcount.
The number of representatives times the standard divisor is equal to the population of the state minus the number of misrepresented people in that state.
The correction factor subtracts the percent overcount from the census data, then increases that data proportionally to the number of undercounts.
Ideally, you want a purely proportional system. Let's pretend you have 5 seats and 2 states, the red and the blue state.
Our modified Zepf-Landau method is optimal because it prevents gross dilution and inflation of party votes.
Oh, they were very good, very well presented, clearly innovative ideas, and they obviously put a lot of work into it. And to come up with the ideas they did in such a short time, it was very impressive.
The winners of the Moody's Mega Math Challenge for 2010, Montgomery Blair High School Team 141 from Silver Spring, Maryland.
The goal is to spotlight applied mathematics as a powerful problem-solving tool, a vital contributor to society, and as a viable and exciting profession.
Well, I thought it was a really great experience and a great opportunity to participate in. And obviously there's the scholarship, which is an added bonus.
Being here is a great way for students to experience the business world. They get to present their paper, their ideas. So it's a good learning experience as well as a real life experience.
I think it's tremendously important, especially getting involved in this project, seeing how pertinent it is to the everyday life of the average American citizen, and seeing the tremendous role statisticians and mathematicians can have on American society. That was tremendously valuable for me and important.